Okay, next thing is the Pearson's correlation coefficient, also called little r. So this is a way of giving the strength of the relationship an actual number. So, and this only applies to linear relationships. So it's an the strength of the linear association is an indication of how closely the points in the scatter plot fit the straight line. So if they really lie on it perfectly, then you can say you've got a perfect positive linear association, and we'd call that 1. So this one has 1 going that way. Whoops, a bit wonky, but you know what I mean. And or if it's going in the negative direction, it has a perfect thing of -1. So also a bit wonky, but you know what I mean. If there's absolutely no correlation at all between anything, it's 0. So the Pearson's correlation coefficient ranges from 0 to 1. Oh, sorry, from -1 to 1. So here are some examples of what they look like. So that's 0.9 is quite close to being a perfect correlation. You know, here is -0.3. It's not a very strong correlation at all. So a strong association. I shouldn't use the word correlation. That comes later. Okay, so then the Pearson's correlation coefficient. It's just a summary of what I've just said there. It looks at the strength of relationships. So let's have a look at the one that we did the other day, the number of hours studied and the mark. So this is the one we did before. Now, your graphics calculator will give you the Pearson's correlation coefficient as well, but it's also on Excel. If we went to the trend line like we did before and get the line of best fit, go to more options, go right down here at the bottom. When we displayed the equation on the chart the other day when I showed you, but you can also get what is called R squared. So if you've got R squared is equal to 0.893, let's go back to the other one, 0.893. So if R squared equals 0.893, then R, or little r I should call it, that's what they use in the textbook. Little r is the square root of 0.893, and this would be 945 for 3 decimal places. 945. That's a very strong R, that one. If we look at our picture again, it does look like a fairly strong correlation. And the dots aren't very far away from the line. So go back to this one here. So interpreting the correlation coefficient. So this one, very strong. That's what we got. Okay, a very strong one there. And then obviously moderate, weak, no linear association, then weak negative, weak, moderate negative, and strong negative. So positives and the positive, negative and the negatives. They do tell you to remember a few things, that you use the value of the correlation coefficient as a measure of the strength of an association. You're implicitly assuming that the variables are numeric, the association is linear, and there are no outliers. So otherwise you may be misleading.